pins, which are the 3 pins that we talk about, plus the one for CS. So CS is included in the port, in the port, because each slave should have a CS. And then we have 3 functions: receive, read, and reply. So receive is to check if there is something, if we have received something in the register. When we call write, data will be transmitted from here to here. If I put y here, so we call the function, the data will go from here to here, and this y will come from the slave to the master. So we need to keep checking. We don't know when the data is ready, right? So this receive function, which returns true or false, we use it in an if statement. So if received, then we read. If don't receive, then we keep checking until the data is there. So if received, then we read. Retrieve the data from receive buffer of slave. So we get the data, we read it. So read function is to read the data that has been received. And then usually a slave, once you have data, you receive the new data, you read it, and then you push the new data to be transmitted in the next time. And this is what we keep doing. So we read the data, and then we put new data to be sent next. We do this with reply. So we fill the transmission buffer. The buffer here is the shift register, by the way, yeah? With the value to be written out as slave on the next received message from the master. Is this clear? Because we need to reply. We need to put a new value for switches. Each time we get a new value from the master, we need to put a new value to be transmitted next, and so on. So those are the functions that need to be used for the slave. And this is the code for the slave. So as you can see, I configured it as SPI slave. I have an extra pin here, pin 14. So SPI slave, you need to put 4 pins. The 3 pins that you know, MOSI, MISO, and the clock, plus this is for CS. We have LEDs, bus out, bus in. This is the same parts as the other one. And we have switch word and receive value, again, to be sent and to be received. Again, switch word, we assign SW to it. Configuration, I didn't put anything, so which means is the default values like I did for the master. And then this is the part that, and you will see those are the parts that you will repeat every time you need to send and receive data. So if we are checking receive, so if this is true, then we do LEDs is equal, we get the new data, and then we assign the received data to LEDs. If this is false, you know, the previous data will be still assigned to LEDs, so nothing will happen. This means we didn't receive new values for switches. Now, if it's true, and then we just read the value, so we call the function read. So the value will be assigned to received value. And then we push the new value for switches, which we read here. So we push the value to be sent in the next transaction or in the next transmission. So we need to reply. If you don't call a reply, what will happen? We will keep always having the original value that was in, not the original, the value that was received from the slave will be sent back to the slave or to the master. If I don't call a reply, so let's say this is the, let's say that we have 1, 1, 0, 0, 0, 2 switches are on. And here we start with 2 switches are off in the master, right? So this is what will happen. So we do the first transfer. So the first transfer, we will have 1, 1, 0, 0, 0, 0, 0 here. And here we will have 0, 0, 0, 0, 0. Right? And then the LEDs will be off for the slave, the master, and the LEDs will be on for the slave. The next time, because we have while one, yeah, so next time we are going to change. Let's say that the values of the switches will change from for the master there will be 0 1, the new values for the switches, and the new values for the slave for the switches is 1 0. So which means in the next time we need to transmit 1 0 from the slave and 0 1 from the master. If I don't call reply and I don't put the new value, this new value, because I read this, I assign it to switch word, right? So if I don't call reply and I don't put this new value, what will happen? The next time this will be transmitted and we get back this one, 1100, which was sent previously from the master to the slave, will be transmitted back to the slave, to the master, sorry. So what was sent in the previous transmission stays in the shift register of the slave, and it will be sent in the next time the master requests data. And it will get the same data that it sends previously to the slave. So we need, it's very important to call the function reply to push the new value to be sent in the next transmission. I hope this is clear. And you will see, as I said, it's the same part of the code that will be repeated. You check, you read the data, you push the new data to be sent, and that's it. And from the master side, it's much easier. So you write a function write, which does everything. So it does the transmission, and then it reads the data. So this write, the write basically it writes and it reads as well. Is this clear? Right, so we'll do a tutorial. So you'll have more examples about this, and you can ask questions if something not clear. Of course, you can connect more than one microcontroller to the master. So I can have 2 microcontrollers as a slave and 1 as a master. This is very simple example, but usually, in real applications, sometimes you have embedded systems with multiple microcontrollers. When you have to do computationally intensive tasks. So one microcontroller cannot take the whole load. So it needs to be shared by different microcontrollers. And then, of course, one will be the master. So the others will work for it. They will do calculations. And then they will send the result to the master. And the master will use the result and do things that it needs to do. So one is like managing, and the others are working for it, getting the data, calculating the data. Because if you put everything in one microcontroller, for example, in real-time applications, you will not have a real-time response, because you have a very large code and it will be very slow. So we do like parallel processing. We have multiple cores working together in one application. Again, this is the simple code just to show you how to send data. So sending data is the same way. You will send it the same way. By using SPI, of course. I'm talking about SPI here. Right.
Doctor?
Yes.
Yes, I had a question regarding the clock frequency here.
Yes.
Is this frequency provided by any separate chip, or is it controlled by the main processor that is in the M? So what will be the maximum limit for the clock frequency here in Mbed? Is it 96 megahertz as the main processor, or controlled by the chip?
There is an extra, clock source, or clock chip, as you said. So if we this one, So when we talk about SPI, we have this circuitry inside the microcontroller connected to the SPI port. So there is a clock source here. That is programmable, of course. It can, for SPI, you can go up to 70 megahertz. Does this answer your question, or?
So it's not controlled by the, or it's not dependent on the main.
It's a clock source. It's an independent clock source that is connected to the S clock, which is an output from the microcontroller within this port, of course, the SPI port.
And if I want, I could change the source to make it appropriate for the application, for example, right? Or is not possible?
What do you mean by change the source? You configure
I mean,
the frequency. You can change the frequency.
sorry, I meant like let's say with the with the computer. So I would have to go for the frequencies in gigahertz. So it won't be possible using the clock on the embed.
No.
So,
You cannot. You cannot go in gigahertz because we said the SPI standard or the protocol. The maximum frequency that you can work with is 70 mega. You will not find an SPI device that operates with a frequency more than 70 megahertz. In the market, there is no SPI device that works with more than 70 megahertz. So 70 is the maximum. So you go to buy the device, you go to the datasheet of the slave or the sensor, you will find it always less than 70. So based on this, so if you find it is 4 megahertz or it says 5 megahertz, you need to work with the clock, the clock that you need to generate from the master, it needs to be maximum 4. And you configure this with the format. I don't know what's to be honest, I don't know what's your problem with the clock. It's just the clock that you need to configure that needs to match the one for the slave. And where do you find the information for this? It's in the slave datasheet. And the maximum frequency is 70 megahertz. Up to 70. Is this clear?
clear. Thank you.